In the previous lecture, I left the discussion with two questions. The first one is how to visualize two-dimensional and three-dimensional arrays. And the second one is why we are multiplying the sizes which are mentioned in those square brackets in order to calculate the size of the array. I'll discuss those two questions in terms of two-dimensional arrays in this lecture. And also I will discuss more about two-dimensional arrays. So let's get started. First of all, the basic form of declaring two-dimensional array is you have to specify the data type, then the name of the array, and then within these square brackets you have to specify the sizes. X and Y here represents the size. Okay. Now let's address our first question, that is how to visualize two-dimensional array. Recall that a multi-dimensional array is an array of arrays, right? A multi-dimensional array you can imagine as an array of arrays. That is the combination of multiple arrays. And please also recall how to declare a 1D array. We can declare 1D array using this statement. You have to specify the data type, the name of the array, and just a single size you have to mention. And how we can visualize a 1D array? This is the usual way of visualization. We imagine a 1D array as a single row which consists of multiple blocks, and the number of blocks is basically equals to the size that we have mentioned. If it is 5, then there are 5 blocks. Okay? This is the way how we can visualize a 1D array. Now if we add one more dimension here, then it becomes a 2D array, isn't that so? But how we can visualize it? This simply means we require 4 such 1D arrays which consist of 5 blocks. That is 4 1D arrays which consist of 5 blocks each. Okay? They are quite far away, isn't that so? Let's see what happens when we combine them together. It forms up a matrix, and the size of this matrix is 4 cross 5. It consists of 4 rows and 5 columns. Isn't that so? So we can say that a two-dimensional array is basically a matrix, right? Here in this case it is 4 cross 5 matrix because it consists of 4 rows and 5 columns, right? This is the way we can visualize a two-dimensional array. And how many elements does this array consist of? It consists of 4 into 5 elements, that means 20 elements. So what is the conclusion? This first size means the number of rows and this means the number of columns. Okay? And in order to multiply the size of any two-dimensional array, we have to multiply the number of rows by number of columns. In this case, we will multiply 4 by 5, which gives me 20. This array is capable of storing 20 elements. And if we want to calculate the size in bytes, we will simply multiply 20 by 4. I'm assuming here that the size of one element is 4 bytes. Therefore, I will multiply this 20 by 4 and it gives me 80 bytes. So the size of this array in bytes is 80. Let's see how we can initialize two-dimensional arrays. In order to initialize two-dimensional array, there are two methods that I'm going to discuss. First method is this. We can initialize two-dimensional array by simply mentioning the elements inside these curly brackets. Okay? As this array consists of 2 rows and 3 columns, so let me draw them over here. And please note down that index always starts from 0. When I'm saying 2 rows, the index starts from 0 and ends at 1. And when I'm saying it consists of 3 columns, that means index starts from 0 and ends at 2. And how the elements are stored in this array? The first element stores at this particular location. Second element stores at this location. Third element stores at this location. Fourth element stored at this location. Fifth element stored at this location. And sixth element finally will get stored in this location. Okay? All the elements here will store in a consecutive fashion. But sometimes it is confusing. There is one better method of initialization which I am going to discuss next. And here is this method. This will also initialize this array in this form that we have seen previously. But the beauty of this initialization is we can visualize it properly. This depicts the row 1 and this depicts the row 2. Okay? Now after having a discussion on initialization, let's talk about how we can access 2D array elements. Using row index and column index, we can access 2D array elements. For example, we can access element stored in first row and second column of below array like this. We have to specify the index, that is, row index must be 0, that depicts the first row, and column index must be 1, that depicts the second column. In order to access the first row second column element, that is this element, we have to specify the row index as 0 and column index as 1. Okay. Now, after having a discussion on how to access 2D array elements, let's learn how to print 2D array elements. We can print 1D array elements using single for loop. Isn't that so? Like suppose you have this array, which is a single dimensional array. We can access the elements of this array by using a single for loop, which is very easy to write by initializing I to 0 and specifying the condition as I less than 5, because in this case the number of elements is 5, and then this increment statement. And inside this for loop, we will use printf function to print all the array elements. Now, in order to print 2D array elements, we will simply use two nested for loops. That is the basic idea. That is, if you have a 2D array like this, then we can print all the elements of this array by using these two nested for loops. Let's see how we can print all the elements of 2D array using two for loops. Please recall that the example consists of 2 rows and 3 columns, right? That is, in the conditions there is a need of writing 2 here and 3 over here. Initially we will initialize this I by 0, and then we will check this condition is I less than 2 or not. Yes, I is less than 2 because I is 0. Therefore, we will come inside this for loop and we will initialize j to 0. After initializing j to 0, we will check this condition is j is less than 3. Yes, 0 is less than 3, right? Again the condition is satisfied. Therefore, we will land at this point and we will print aij. This means we will print a00 because I is also 0 and j is also 0. A00 means we are accessing the 0th row and 0th column, that is this element. Therefore, this element will get printed on the screen. And then after that, we will land at this point, that is we will increment the value of j. J now becomes 1. Now we will check this condition is 1 less than 3 or not. Yes, 1 is less than 3, therefore condition is again satisfied. We will come at this point, we will print A01. That is 0th row and first column. This element we will print on the screen. After this again we will increment the value of j. J now becomes 2. 2 is less than 3. Again the condition is satisfied. Therefore we will print the element stored at 0th row and second column. That is this element. This element will get printed on the screen. After that again we will increment the value of j. J now becomes 3. 3 is not less than 3. Condition is not satisfied. Therefore we will come outside of this for loop. At this point, after this for loop we won't find anything. Therefore, we will increment the value of I next. I now becomes 1. 1 is less than 2. Isn't that so? Condition is satisfied. Therefore, again we will go inside this for loop and again we will find the for loop. This means the j will again get initialized by 0. Please note that I is 1 in this case and j will again get initialized by 0. Again we will check the condition. Is 0 is less than 3? Yes, 0 is less than 3. Condition is satisfied. Therefore, we will print the value stored at row index 1 and column index 0. That is this element. This element will get printed on the screen. After that, we will again increment the value of j. J now becomes 1. 1 is less than 3. Condition is satisfied. Therefore, we will print the value stored at row index 1 and column index 1. Row index 1, column index 1. That means this element 5 will get printed on the screen. After that we will increment the value of j again and j now becomes 2. 2 is less than 3, condition is satisfied. We'll go inside and print the value stored at row index 1 and column index 2, that is this particular element. This will get printed on the screen. J now becomes 3. 3 is not less than 3, right? Condition is not satisfied and hence we will come outside of this for loop. That is, again we will increment the value of I. I now becomes 2 because previously the value of I was 1. Now it becomes 2. 2 is not less than 2. Condition is not satisfied. Therefore, we will come outside of this for loop and hence the program finishes its execution. Okay. Therefore, the final output is 1, 2, 3, 4, 5, 6. That is all the elements which are stored in this 2D array. This means that this nested for loop structure helps us in printing all the elements of this array. Okay. What we have learned so far? We have learned that how to declare and define two-dimensional array. Then we learned how to visualize two-dimensional array. Then we learned how to initialize two-dimensional array. Then we have learned how to access two-dimensional array elements. Then finally, we learned how to print two-dimensional array elements. Okay friends, this is it for now. Thank you for watching this presentation.